Today we will discuss this type of system, what is the torque of the system and linear acceleration of the system. Okay, here this pulley having the moment of inertia I, and this block having the mass m1, and this block having the mass m2. Okay, first we will find the torque of the system. Listen, we know that the torque is equal to R into perpendicular force. Okay, so in this case the perpendicular force is the normal reaction, and but this is cancelled with the m2g, the gravitational force, and only this mass will provide the perpendicular force. And what is the perpendicular force here? Here also the gravitational force m1g. Okay, m1g, and what is R here? The radius of the pulley. So the torque is equal to m1g into R. Okay, so we got the torque equation. Next we need to find out what is the linear acceleration of the system. So for finding that, we know that what is L? L means the angular momentum of the system. Angular momentum of the system means the angular momentum of the block 1 plus angular momentum of the block 2 plus angular momentum of the pulley. Okay, so what is the angular momentum of the block 1? We know that the angular momentum equation is R cross P, which is equal to R into mv. Here velocity and R are perpendicular to each other, so sin 90 equal to 1. So we can write like this. So what is the angular momentum of the block 1? It is R into m1 into velocity. It is moving downward with velocity v, so it is v plus what is the block, the angular momentum of the block 2, that is here the same equation we can use, that is m1 into R into v plus then what is the angular momentum of the pulley? We know that angular momentum having another equation. According to linear momentum, it is a mass into velocity, so that same expression we can write the analog of mass is the moment of inertia, and analog of velocity is angular velocity. So what is here? L is equal to I into what is omega? V is equal to R omega. So omega is equal to V by R. So we can write I into V by R is the angular momentum of the pulley. So just substitute here. So I into V by R. Okay, then R, everywhere R is there, we can take outside the relation between L and the torque. Then there is a torque is equal to dL by dt, rate of change of angular momentum is a torque. So which is equal to torque equation m1 gr. Okay, then substitute here. So we can write like this, m1 gr equal to d by dt of this term, r m1 v plus m2 rv plus I into v by r. Listen, we can take v and r outside, and r and r cancel each other. So I am taking the r and v outside. Here also r and v, here also r. But suppose here we are taking the r, means the denominator divided by r square will come. So it is we can write it is a vr here. Listen, d by dt of v, velocity, that is acceleration, and these are cancelled each other. So m1 g equal to a into m1 plus m2 plus I divided by r square. And from this equation we can write like this, the expression as a equal to m1g divided by m1 plus m2 plus I divided by r square. Okay, so this is the expression of linear acceleration of the system. Okay, thank you.